The history and structure of atoms. Introduction. Welcome to today's lecture on the fascinating world of atoms. In this session, we will discuss the historical development of atomic theory and the modern understanding of the structure of atoms. Ancient Greek philosophy. In ancient Greece, philosophers believed that matter was composed of indivisible particles called atomos, meaning indivisible. These ideas, however, lacked experimental evidence. 17th century discoveries. In the late 17th century, the study of pure substances revealed that a few elements made up many different substances. Investigations began on how elements combined to form compounds and how compounds could be broken down into their constituent elements. John Dalton's atomic theory, 1808. English schoolteacher John Dalton proposed an atomic theory. Main postulate. All matter is composed of atoms of different elements, each with unique properties. Atoms are the smallest particles of an element that can participate in chemical reactions. Subatomic particles. Modern research has revealed that atoms are composed of subatomic particles. Key particles: electrons, protons, and neutrons. There are more than 100 known subatomic particles, but these three are fundamental. Atomic mass determination. Swedish chemist J. Berzelius, 1779–1848, determined atomic masses of elements. Many of his values closely match modern atomic masses. Berzelius also developed the system of assigning symbols to elements. Evidence of atoms. Atoms cannot be seen directly, but electron microscopes provide indirect evidence. Ordinary optical microscopes have limitations and cannot visualize objects smaller than 500 nm. Electron microscopes use beams of electrons with much shorter wavelengths. An electron microscope image of graphite magnified about 15 million times. Highlight carbon atom layers. 20th century discoveries. X-ray studies have revealed that atoms have diameters of about 2 × 10⁻⁻10 m, 0.2 nm. Masses of atoms range from 10⁻⁻27 to 10⁻⁻25 kg and are often expressed in atomic mass units, AMU. 1 AMU equals 1.661 × 10⁻⁻27 kg. To put this in perspective, consider that a full stop may contain around 2 million atoms. Conclusion. Today, we've learned the history of atomic theory, from ancient Greece to modern times. The structure of atoms and how subatomic particles play a crucial role. Remember, while we can't see atoms with our eyes, science has provided us with powerful tools to study them. Questions and discussion. Now, I'll open the floor for questions and further discussion on the topic of atoms.